All right, let's do a couple more examples here. So it says a survey indicates that for each trip to a supermarket, a shopper spends an average of 43 minutes with a standard deviation of 12 minutes in the store. The lengths of time spent in the store are normally distributed, so we know we are using that normal or bell curve and are represented by variable x. A shopper enters the store. All right, so we have two parts we're going to find here. I'm going to focus on A for a second. I'm not going to worry about B right now. Let's just look at A. So find the probability that the shopper will be in the store for each of the following intervals. So the first problem we're doing between 22 and 52 minutes, and then for the second problem we're doing more than 37 minutes. All right, so I know it's normally distributed. I know I have a nice normal curve. I'm always going to start by drawing a picture. If you don't have to draw the picture, then that's fine. You don't have to always do a picture, but I just think it's so helpful. Now, our average is 43 minutes, so that's our mean. And our standard deviation is 12 minutes. I'm just going to write this down here. And this is going to be the same thing. Okay. And again, this is our x values. So we're not doing z values right now. We're just in the x values, the original data. All right, I want to know the probability that someone will be there between 22 and 52 minutes. So 22 minutes is much smaller than 43. It's going to be like maybe way over here. And 52 is not that much bigger, so maybe it's a little closer, but it's bigger, so it's on the right. So you just want to make sure that you put your numbers in the right positions. And we're going in between. So I'm looking for this region in here. For the second example, we're going with more than 37 minutes. So first of all, 37 is smaller than 43, so not too much smaller though, so maybe it's like right here. So it's going to go on the left, and then I want more, so I'm going greater than. So these are the two regions that I'm trying to find in my examples. Now, if you're using technology, again, these are pretty quick. So for technology, we're going to hit that second bars key, normal CDF. Now, looking at the shading, our lower shaded limit is 22 and our upper limit is 52. Our mean is 43 and our standard deviation is 12. For this one, again, we're going to do second bars in that normal CDF. Here, our lower limit is 37. And we are unbounded going up, so it's going to keep going, so we can use a big number like 99999. Our mean is 43, and our standard deviation is 12. So I'm going to go ahead and just type those values into my calculator, and we'll see what we get. So 22 for my lower, 52 for my upper, mean of 43, standard deviation of 12. And I get, I'm going to round to 4 decimal places here, so about 0.7333. And then for my other one, I have second bars, again, normal CDF. My lower limit is 37. My upper limit is unbounded, so I'm going to use a large number. My mean is 43, and my sigma is 12. So I have about 0.691, and then rounding to 4 decimal places, that 4 is going to bump up to 5. So for the first part, find the probability that the shopper will be in the store for each of the following intervals. Well, we have it. Remember, probability equals area. So the probability in the first answer is 0.07333. Sorry, the probability in the second answer is 0.6915. Now, before we get on to part B, if you're not using technology, that's okay, but you have to convert to z-scores. So I'm going to do that with you guys in this one more time, okay? So if you're not using technology, we're going to convert these over. So when we convert over, your center is going to be now at 0, and your standard deviation is 1. Okay, so we're converting over to the standard normal distribution. And again, this is what you're going to do if it's asking you specifically to find z-scores, or if you're not using technology. I do strongly encourage you to use technology because it's going to make your life a lot faster. But if you don't want to, then that's okay. So your pictures are still going to be the same. We just need to find out our cutoffs in the terms of z-scores. Okay. All right, so let's do some different colors here. So for this z-score right here, again, the formula is to take the x value and subtract the mean and divide by the standard deviation of your original numbers, okay? Not these ones, the original numbers. So our x value there was 22, the mean was 43, and the standard deviation was 12. So you're going to subtract 22 minus 43 first, divide by 12, and when you get that, you're going to get that z is negative 1.75. And then we're going to do the same thing for this one. So my original value was 52, my mean is 43, and my standard deviation is 12. So when I divide, I'm going to get 0.75. And I'm just going to keep going. We'll do both of them at the same time. So this one over here, again, my original value was 37. My mean was 43, and I'm dividing it by 12. And what I get here is negative 0.5. Notice that z-scores to the left of the mean are always negative, and z-scores to the right of the mean are always positive. So that's a nice check as well, just to make sure everything's lining up. If something's off, then I would go back and check your work. All right, so now we're going to assume we're using the table here. So I'm going to go ahead and bring out that table, and let's see what color. We'll use orange, I guess. Sorry, it just takes a long time to get all this stuff out. All right, so here's my negative table. I'm going to look at negative 1.75. So there's negative 1.7. And then I want to go over to, I get to 5, which looks like it's about right here. Yeah, so that matches up. So I get 0.0401. Okay, so again, what that represents, that actually represents this area to the left. So remember, if you're using a table, it's the area to the left. And then I need to do my z-score for 0.75. I go to the positive side, there's 0.7, going over to that number 5, and I have 77.34, so 0.7734. And remember as well that when you're doing your probabilities, this represents the area to the left, so it's this whole piece here. When you're finding the area in between using a table, you have to subtract. So remember that, and this is from one of the last videos we did a couple of videos ago, that if you're finding that area in between and using the table, you do have to come in here and subtract. And when you do, you'll see that our area does match with technology. So remember, for in between, you have to subtract. If you're using the table. If you're not using the table, then you don't have to, but it's just if you're using the table. Now for this one, if we're using the table, again, I still have to find that area. So I'm going to go back to my table and find that 0.5 mark. Okay. So it's way down here. And then I would go all the way to the right to find that 0. It's 0.50, and I get 0.3085. Okay. But you want to remember, in the table, it's always the area to the left. So that's not what I want. I wanted the other side of it. So when you're finding the other side, we're subtracting with 1. So remember, when you have the area to the right, you're going to subtract with 1 instead. So I'm going to do 1 minus 0.3085. And I get 0.6915, just like I did with technology. Yeah. So again, don't do both of these methods for every single problem. I want you to pick one. If the question just says to find the values and you don't have to find z-scores, again, I would use technology. It's substantially faster. And I think it just makes more sense. I think the table is great, but it's a little outdated now that we have technology. So if you're using the table, it's fine, but just make sure that you know how to use it when you don't have the area to the left. So if you're in between, you're subtracting 2 areas, and if your area is to the right, then you have to subtract with 1 to get the right answers. All right, now there was a part B here. Sorry, let me grab my answers back out. And it says, when 200 shoppers enter the store, how many shoppers would you expect to be in the store for each interval of time listed above? So this question I think sounds a little bit confusing, but it's actually pretty straightforward. All we're going to do is take that value of 200 and multiply it by our probabilities. And we'll be able to get the answers there. Let's see if I can use a different color for a second. So, turquoise. All right, so for part B, for the first one, so if 200 shoppers enter the store, then all you need to do is take that 200 and multiply it by your probability. So 0.7333. Again, I'm not lining this up because I'm going to do it on my calculator. And when I get that, I get about 146.66. Now, we can't have 0.6 of a person, so I'm going to round this. So it's about 147 shoppers. And then for the second one, again, we have 200 shoppers in the store. Our probability was 0.6915. So basically we're looking at, well, what's 69.15% of 200? So really we're just doing a percent calculation here, but leaving it with probabilities. So when I multiply that 200 times 0.6915, I get about 138.3, which is about 138 shoppers altogether. All right. Now, one last thing before I move on. So I have been doing a ton with notation here, but if you see some notation, I just want you to be aware of it. So for instance, on this first one, because we were going in between, you could write this as the probability that X is between 22 and 52. So you may see some notation like that. You can either write less than or equal to. It's actually not going to make a difference in their answer. And when you're doing the z-scores, so that will convert over to being the probability of negative 1.75 is less than z is less than 0.75. So we can just use this probability notation. If you see it, I don't want you to be shocked by it. It just is the same thing we're doing here, just writing it a little bit more formal. So in this case over here, we were looking at the probability that X was greater than 37. Or if you had a z value, probability that z was greater than negative 0.5. So just using that notation, he's still for probability here. All right, one final example. In this one, I'm just going to focus on technology here, but you're welcome to still convert to z-scores as well to find your values. So triglycerides are a type of fat in the bloodstream. The mean triglyceride level for U.S. adults ages 20 and older is 97 milligrams per deciliter. We're going to assume the triglyceride levels of U.S. adults who are at least 20 years old are normally distributed with the standard deviation of 25 milligrams per deciliter. You're going to randomly select a U.S. adult who's at least 20 years old, meaning that they're in the category we're talking about here. What is the probability that the person's triglyceride level is less than 100? And just as a note, triglyceride levels less than 150 are considered normal. So I know that it's normally distributed. I'm going to make a picture. For me, that's how I always start. I know my mean level is 97. So that center here is at 97. And my standard deviation is 25. I always just like to write it somewhere. You don't have to write it at the center. I just like to put it somewhere on my grid so I don't forget about it. And we're looking for levels less than 100. Now 97 is my center, so 100 was bigger than that, so but not much. So maybe like x equals 100 is right here. And I want values less than, so I'm looking for this area, right? Anything smaller. Less than, think left. We're shading. Now again, I'm going to skip this part because we've done quite a few examples already, but if you want to convert to z-scores and use the tables, we're going to do it the same way that we did up here or in the last example. I'm going to focus on technology this time because again, it's so much faster. All right, now my lower bound for my shaded region, I don't have one. It's going to keep going left. So I get negative 9999. My upper bound is clearly at x equals 100 though. My mean is 97 and my standard deviation is 25. So if I just plug this into my calculator, they can handle it all for me. I don't have to worry about subtracting anything like I would with the table. So, although in this case, actually, the table works fine because it's going in the right direction. But if you had something different, you'd have to worry about it. All right, so lower bound, negative 9999, going up to 100. My mean is 97, and my standard deviation is 25. So I get about 0.547758, or about 5478 if I round to 4 decimal places. So that 5 is going to bump that 7 up to an 8 there. So the probability that x is less than 100 is about 0.5478. And again, probability equals area. So we use those terms interchangeably. If it's asking you for the area or if it's asking for the probability, it's the same exact thing. So the probability is about 0.5478. So about 54.78% of people in this age group, so ages 20 and older, have triglyceride levels less than 100. Now, there are other ways to use other technologies. So if you like Excel, if you go into your textbook, it actually will give you the formula that you can use there for Excel instead. I think the calculator is pretty quick here because you don't have to enter any large data sets. You just need to know a couple different values and you can find it out. But if you'd like to use Excel, again, I encourage you to check out your text. They do have the formula that you can use right in there so you can follow along that way.